Okay, we're in section 4.2 and we have already looked at some graphs of exponential functions, and now the next objective is to solve some exponential equations. What makes an equation an exponential equation? Well, it's when the variable is in the exponent. And so you see the first couple examples. There's a basic strategy that we want to apply in each of these problems. And we'll get to that as we work through this first example. So if I have 8 equals 2 to the x, maybe it's clear right away what the answer would be. Let's see, what power of 2 is 8? I think that's 2 to the third power. So the answer is going to be x equals 3, but let's make sure we have a systematic approach to get that. So what I want to do is I want to rewrite the two sides of the equation so that they have the same base. And so if I have a base of 2 already on the right side, I would like to rewrite 8 on the left side using a base of 2. So again, I'm asking the question, okay, 8 is 2 to what power? And so I can say that's 2 to the third power. And now I have 2 to the third equals 2 to the x. And so maybe it's clear to you now that if the bases are equal, then the exponents must be equal. Right? There's no way x can be anything else except for 3. So we'll have 3 equals x, or you could even write x equals 3. Okay, so the basic idea now is to get the base the same on both sides of the equation. Get the same base on both sides of the equation. Then what we do is we drop the bases and we set the exponents equal to each other. Then set the exponents equal to each other. And so the problems will get a little more difficult than this first example. So let's look at the next one. We have 1/3 raised to the x is equal to 81. And so we need to be asking ourselves, what would be a good base for these two numbers to share? And with a little thought, you might realize that 3 is a good base. That 81 is the same as 3 to the 4th power. If that seems difficult, 9 squared is 81, and 9 is the same as 3 squared. So the other thing that you need to know is that 1/3 is the same as 3 to the -1 power. And I believe we talked about that in a previous video. We said that a over b to the nth power is the same as b over a. So let's put a negative sign there and a positive sign there. So let's have a over b to the -n is equal to b over a to the n. And so what that tells us is that we can turn 1/3 into 3. That's the reciprocal. That's switching numerator and denominator in the base. Instead of a over b, we have b over a. And then the only thing we have to do with the exponent to make that work is just change the sign on the exponent. So here inside the parentheses, we have 1/3 to the 1st power. So that's the same as 3 over 1 to the -1st power. Okay. There's another property of exponents we need right now. That property says a to the m raised to the n power is the same as a to the m times n. A to the m times n. So here, 3 to the negative 1 raised to the x is the same as 3 raised to the negative 1 times x, or just negative x. Now we have our bases the same, so we can drop them away. We can just set the two exponents equal to each other. We can say negative x equals 4, or we can divide both sides by negative 1 and get to a final answer, x equals negative 4. And of course, you could check this answer by plugging it in to the original equation and then simplifying the left-hand side, or even putting it into a calculator. Okay, let's do a couple more. So here in part C, we have 4 raised to the x plus 3 is equal to 8 raised to the x minus 6. You might want to pause the video if you think you have an idea for that common base. Four and 8 can both be written with a base of 2. We can write the left side. On the left side, we can write 4 is 2 squared raised to the x plus 3. And on the right side, 8 is the same as 2 cubed, and that's raised to the x minus 6. And so then we just learned that we can multiply these two exponents together. 2 times x plus 3 is going to be 2 raised to the 2x plus 6. Make sure we distribute that 2 to both terms in the other exponent. On the other side, you have 2 raised to the 3x minus 18. And we've got the bases the same, so let's set the exponents equal. 2x plus 6 equals 3x minus 18. And then if we subtract 3x from both sides, we get negative x. And if we subtract 6 from both sides, we get negative 24. And so x is equal to 24. Okay, a couple more to go. In part D, square root of 3 raised to the x plus 9 is equal to 27 raised to the x. What's a good base? A good base would be 3. Do you remember how to write the square root as an exponent? The square root of a is equal to a to the 1/2 power. Remember, there's an index on every root. When the index is not written, we assume it to be a square root, or an index of 2. And then we should go ahead and write, if you have, say, the nth root of a, then that would be the same as a to the 1 over n. Okay, since I used blue out on the side, maybe I'll change and use green here to solve the problem, just to keep things clear. So the square root of 3 is the same as 3 to the 1/2 power, and then that's raised to the x plus 9. And then 27 is 3 to the 3rd power, and that's raised to the x. So we can distribute the 1/2. We can write 1/2 times x plus 1/2 times 9. And on the other side, we have 3 raised to the 3 times x. Bases are the same, so we'll set the exponents equal. 1/2 x plus 9/2 is equal to 3x. There's more than one way to solve this problem. You know, back in at the very beginning of the semester, we learned to clear out the fractions in an equation like this. So if we multiply by so let's try that. Let's multiply by the least common denominator, that's 2. and then we'll have the 2's cancel, and we'll be left with x plus 9 is equal to 6x. And we can subtract x on both sides. 9 is equal to 5x. We can divide by 5 on both sides, and x is equal to 9/5. And there's our answer. Okay, so those are exponential equations. And again, the big idea is to get the bases the same and then set the exponents equal to each other. Later in the chapter, we're going to learn another way, a different way to come back and solve these equations. But that's coming later on. I have one more equation to solve, but it's a lot different. Can you see what's different about it? The variable is not in the exponent. This is not an exponential equation. This is not an exponential equation. It seems a little bit out of place for that reason. But it's good for us to do here because it will help us with another problem that's coming later in this section or in the next section. Okay, so the base, so the variable is back down in the base like it used to be in chapters 1, 2, and 3. And so we need to isolate x. Probably the quickest way to do that would be to raise both sides of the equation to the reciprocal power. To the reciprocal power. Let me write that out, and then we'll get a better look at it. So let's write x to the 2/5 is equal to 16, and then let's come through and raise both sides to the 5/2 power. And what's good about this is the rule for exponents tells us to multiply 2/5 times 5/2, and we're left with just x here on the left side. So we've isolated x in one step. Now we have to be real careful here as we evaluate 16 to the 5/2 power. There's more than one way to do it. I think what I'd like to do is I'd like to come out to the side and remind you that a raised to the m over n is the same as a to the m raised to the 1 over n, or a to the 1 over n raised to the m. And so this is a direct consequence of this multiplication of the two exponents. M times 1 over n gets you back to m over n, and of course the order of the multiplication doesn't matter. So what I want to do is I want to deal with the numerator and the denominator separately. I want to deal with the denominator first. That's going to make the numbers more manageable. And I'm going to come off to the side here, and I'm going to write this as 16 to the 1/2 to the 5th. And then that's the same. We just talked about that fractional exponent. The 1/2 power is the same as the square root of 16 raised to the 5th power. And then we have 4 raised to the 5th. Square root of 16 is 4. And then powers of 4. 4 to the 1st is 4. 4 squared is 16. 4 to the 3rd. Those numbers are going to get a little big, aren't they? 16 times 4 is 64. 4 to the 4th. 64 times 4 is 256. and 4 to the 5th is 1,024. And you could work that multiplication out, or you could even use your scientific calculator to get that answer. So 1,024 is a good answer. However, it's not the only answer. It's not the only answer. There's a sneaky thing that happened here. When we took the 5/2 power, what did we really do? One of the things that we did is we took the square root. Right? The 5/2 power is equivalent to a square root and then the 5th power. Remember what happens when you take the square root of both sides of an equation. Remember what happens. You get a plus or minus. You get a plus or minus. And so the correct answer is going to be x equals plus or minus 1,024.